Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Hafiz bin Muhammad Razali, and I'm here today to present to you about paper chromatography. Before I explain more about paper chromatography, let me introduce our group members. Our group consists of three members, namely me, Muhammad Amir Hafiz bin Muhammad Azali, ID student 2020-893206, group RAS 115-3E. Next, Muhammad Azizi bin Syamsuddin, ID student 2020-491016, group RAS 115-3E. Lastly, Haziq Daniel bin Azam Hazman, ID student 2020-829018, group RAS 115-3E. The objective of this experiment is first, to use paper chromatography to identify whether certain unknown mixture of colorful dyes are pure substance or mixture. Next, to obtain a paper chromatogram of various unknown mixture of colorful dyes. Lastly, to identify components of unknown mixture of colorful dyes by calculating RF values. Chromatography is a method of physically separating mixture into its individual components. It is a common laboratory technique used to identify unknown component in mixture. We cannot tell if each dye's color is a combination or a pure ingredient by looking at it. The components of a sample move at various rates along the filter paper in chromatography, causing them to spread out and become separated from one another. Chromatography can be used to separate inks, dyes, pigment in plants, or used to determine the chemical composition of substance.
Assalamualaikum warahmatullahi wabarakatuh. My name is Haziq Daniel bin Azam Asman. I'm from RAS 115-3E, and my matrix number is 2020829018. Now, I will talk about the procedures of the experiments. First step, a line was drawn on the bottom part of the chromatography paper by using a pencil. Next, capillary tube were used to take a small amount of ink A which colored yellow. A drop of ink A was put on the line drawn earlier at the paper by using the capillary tube. Next step, step 2 until 3 was repeated with the ink B which colored black, ink C which colored red, and ink U which indicates an unknown solute. The drop was put not so close to each one of them. Next, 50 ml of sodium hydrogen carbonate solvent poured into an empty beaker. Next, the top part of the chromatography paper is wrapped around a wooden spline. A paper clip is then used to hold the paper firmly. The wooden spline was placed on the beaker with the chromatography paper hanging with it. Next, the ink A, B, C, and U changes can be noticed after a few minutes. The paper then was taken out and dried. Next, a line is drawn to indicate the distance travelled by the solvent. Next, the color spot is measured separately by using a ruler. Keep in mind that the spot must be measured at the middle part of it. Last step, the result obtained was calculated and recorded on a table. Now, I will explain the results and data. As we can see from the table, the distance travelled by the solvent, which is sodium hydrogen carbonate, has the same value. This is because we use the same solvent on the same chromatography paper. Next, the distance traveled for the spot color have different values. This indicates that the molecules were being separated into different parts and length. The RF value can be calculated by using the formula distance traveled by solute, uh, or in this case we use ink, over distance traveled by solvent, which is sodium hydrogen carbonate. As we can see in the table, there are some separated parts of value for the distance traveled and the RF value for the same ink. For example, the RF value of ink B separated into two parts. This indicates that there are molecules that were separated from each other, and then we can obtain a different data from the same ink, which is ink B. Now I will explain the discussion of the experiment. When a colored sample is placed on a chromatography paper, in this experiment we use ink A, B, C and U. The colors separate from the sample when one of the papers is immersed in a low-level solvent, which we use in this experiment is solvent sodium hydrogen carbonate. According to the polarities of the molecules and the solvent diffuses up to the chromatography paper, dissolving the various molecules in the samples. If the sample has more than one color, it contains more than one type of molecule, as I explained earlier from the table. Because of the differences in the chemical structures of each type of molecule, the chances are that each molecule will have at least a slightly different polarity, resulting in each molecule having different solubility in the solvent. As the solvent moves up to the paper, the different color molecules leave the solution at different spots due to their varying solubilities, and as a result, the higher a molecule moves up to the paper, the more soluble it is.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azizi bin Samsudin. So I will continue our rap report progress with discussion part. This result obtained is the same as expected as this lab is done theoretically through online discussion. The objective of this experiment is fulfilled and we are able to answer all the questions regarding this lab work experimentally and theoretically. Furthermore, we were completing all the chromatography and lecture notes. From what we understand on the concept of paper chromatography, the mixture is dissolved in a fluid solvent and it is called the mobile phase, which transport it travel at varying appearance velocities in the mobile fluid because they have very attraction for the stationary phase and are held for different amount of time based on their interaction with its surface sites. As a result, they separate. The separation is predicted on the mobile and stationary phase being partitioned differently. Differences in partition coefficient of a compound cause differential persistence on the stationary phase which affect separation. Chromatography is a technique for separating mixtures that involve the use of a moving liquid and filter paper. Near one end of the paper, a drop of mixed solution is spotted and dried. The end of the paper closest to the spot is then dipped into the organic solvent, but the spot is not submerged. The solvent is in a pool at the bottom of the column and travels up via capillary in ascending chromatography. It is in a trough at the top of descending chromatography and flows down by capillary and gravity. The solvent flows through the spot on the paper, transporting the molecules away from the spot. If the solvent mixture has been properly chosen, each of them will move at different velocity than the others. At a period of time, the paper is taken and dry, allowing the substances to be seen immediately if colored or identified using an appropriate locating agent. The combination of solubility and absorption forces determines the distance a substance travels. In theory, the stationary phase is water, whereas the mobile phase is the solvent. The water may be thought of as being confined in a series of little tubes through which the solvent flows. The solid dissolves in the water of the tube when a drop is seen on paper. As the traveling solvent passes through the tubes, it separates the solute and redistributes some of it in consecutive tubes. It is followed by new solvent at its travels, and the procedure is repeated. Since thousands of tubes are used, a large number of partitions develop, and tiny changes in partition coefficient between various solutes in a mixture result in excellent separation in chromatography. Paper chromatography method also allow us to perform the lab work regarding a mixture, and that enables the separation, identification, and purification of the compound and of the component of a mixture for qualitative and quantitative analysis. While doing this experiment, we face some errors of theoretical issues which may lead to unexpected and different results as expected. First, the solvent used is reached to the line drawn on the chromatography paper and needs to redo this step until the solvent cannot reach the line. This error can affect the dot of colored mixture, which they cannot travel with the solvent. In addition, the result cannot be obtained if the solvent reaches the observed dots of colored mixture. In order to avoid this error to happen, we need to estimate the length of the paper by putting the paper outside the beaker first and observe whether it reaches the solvent or not. If the paper is expected to reach the solvent, we need to fold the paper on the stick one more time until the line drawn cannot reach the solvent. Next experimental error that we found is an error while taking the measurement of the color's travel. This error happened because there was an invisible mark on the paper that made us confused, or our eyes were not straight with the reading scale, which lead to error on measurement. To prevent this error from happening, we need to be more accurate to measure the dye's travel and make sure there is no systematic error on the measuring equipment. Somehow, we also need to keep an eye on possible precautions that need to be wary about while doing this experiment. First, make sure to use a good grade pencil to draw the parallel line in the chromatography paper so that the mark doesn't dissolve in the solvent. The second precaution is that the beaker must always be sealed when the paper is put in it to prevent the solvent from drying out. Lastly, this is the references that we use to refer about paper chromatography.
In conclusion, the objective of this experiment, which is to separate the mixture of the chemical substance, was achieved and done by using paper chromatography method. All of the color mixture samples are successful separated. The RF values for each ink or colored mixtures also have been found and calculated by using the suitable formula. By using this technique, we found that all of colored ring ink consisted of several basic colors such as red, blue, and yellow. In order to achieve a successful experiment, we also need to be careful of unexpected errors and precaution, as it can affect the final result of the inks.